Thank you. Hey guys, good morning. My name is Ankur Gupta. I'm responsible for sales and marketing at Metascale, which is a subsidiary of Sears Holdings. And I have Wuheng. Go ahead.
Hey.
Wuheng Liu, who's one of our architects. So today we wanted to talk to you about 3 T's of Hadoop. But I wanted to give you a quick background. Sears Holdings, as you know it, is Sears Holdings Corporation owns Sears, Kmart, Lands' End, Kenmore, Craftsman. What you may not know is we are also the largest home services company in the US. So we provide over 12 million deliveries, installation, repairs, and such. So we get a lot of customer data. We're also becoming a digital company. As you can go to our stores, we have iPads for most of the checkouts, for research and information, and one of the 3rd largest website in US with over 100 million products. So we are, as a company that's focusing a lot more on digital, we have this data that's growing on our side. So over 3.5 years ago, when we started looking at our digital strategy and looking at how best we can accommodate all the data that is coming to us and make sense, we looked at alternatives beyond Netezza, Teradata, and other machines we had, and started looking at Hadoop. It actually started as a storage solution to us when we needed extra terabyte of storage, and soon became a part of our overall data warehouse ecosystem. So Hadoop, as you know it, is traditionally used for, obviously, the data processing, storage, and whatnot. But at Sears, we have gone beyond traditional usage of Hadoop. Some of you may have attended the presentation yesterday on the whole mainframe migration. So we used Hadoop for all of our batch processing from mainframe to Hadoop systems. We also use Hadoop for the ETL management, and that's what we are going to talk to you about today. So Metascale, just so you know, is a subsidiary of Hadoop, subsidiary of Sears Holdings, to help other companies accelerate their big data journey. And I would invite Wuheng, who's one of our architects, to take you through our journey on 3 T's.
Thank you, Anka. So today our topic of our presentation is the 3 T's of Hadoop. So I guess a lot of you already heard it, the 3 V's of big data. And then what you would ask, what is the 3 T's? Yes, 3 V's is a big data definition. I think several years ago, Gartner made that definition. But in our view, that definition is more or less too static. So we are proposing a new concept called Big Data 2.0. And actually, later in this afternoon, we're going to have another session to talk about that. So if you are interested, and please go to that session in room hall 1. So 3T is a big data 2 concept. And actually, simply put, 3T is a big data 2.0 pattern. It's not a generic big data pattern. It's an enterprise big data pattern. So I would like to know how many of you are from enterprises, really non-internet, or just pure vendor enterprises like us. How many of you are from the non-internet and the non-software, pure software companies? Yeah, I saw some of the hands. So based on our practice in Hadoop, and based on our lessons learned, and based on our practice, and also our vision and understanding what big data should be and what Hadoop can be used at enterprises, we would like to propose and advocate this enterprise big data based on Hadoop. So that's all about. Now, we can visualize this pattern in this circular shape. So we're going to see this circular shape again and again in this presentation. And it has a 3-stage circular process of enterprise big data. So in our view, and big data should not be static, should not just an entity with some properties or attributes, say volume, velocity, or variety. we would like to keep enterprise data moving in a continuous iteration of flow from the source data to data products. And this is the pattern that using this visualized shape, we would like to present this pattern. And in the center of that pattern, that circle, really is the infrastructure that is based on Hadoop. So what we can say about this pattern? Number one, it is a very dynamic, and number two is that it will continue to flow in many iterations. In each iteration, we'll get better data. We'll using the decisions that from the data to support business decisions. So that's that pattern. So Anka, do you want to add anything?
No, I think, so the transformation, and the translate, I mean, this is different from the 3TL that you may have known. And those who are from enterprise, how many times you've seen when you get the same data but different reports out of it, right? So in our case, we have over 2,500 stores. You have the same sales data, but when the report goes to a marketing person or a salesperson, that shows two different outputs generally. So what we do, just in a nutshell, we use Hadoop as a single source of truth for us. We ingest all the data that comes to us, and that's sort of the summary of what we have done on our side. Ingest all the data from different sources, transform it internally, and then translate it. So you have what we call as Hadoop as a gold layer of truth. All your data, structured, unstructured, it's all living in there. And as you know, the storage is really economic these days, so it's really easy for us to have it all within our system, and then translate it every time we need it.
Okay, we know that enterprise data are complicated. We have many heterogeneous systems, legacy, and all different systems and more modern systems. And we want to make complicated things simple. So we use three very simple verbs to describe what enterprise big data management should be. So this is all this 3T is about. So let's go next. So what is 3T? 3T stands for transfer, transform, and translate. So three very simple verbs. So there's a explanation of these 3Ts is a new enterprise big data to bring disruptive change to conventional ETL. So we mentioned ETL here as the anti-pattern that we do data or big data at enterprises. We really want to propose the 3T as a pattern to change, to reverse the trend that we have doing this ETL for many years. So number two is we using this 3T to leverage Hadoop to streamline the data process. And the ultimate goal is to use this pattern to work toward real-time analytics. Okay, this is the 3T goals. There's a few keywords here in bold and red. To simplify enterprise data processing, reduce latency, and to turn enterprise data from raw form to products of discovery so as to better support business decisions. So you will see this circular shape again, and you notice that this three strokes of the circular shape always go in one direction, Anchor, right? It is a class-wise direction. Why should we use this direction? Is that we want to introduce time dimension here. So our goal is to make things, number one, simpler. Number two is better. And the number 3 is that time dimension that your enterprise data go each cycle will moving the data and faster and faster, and finishing that cycle faster and faster. Okay, so if you want to take away from the whole thing, this is a few one-liner about this pattern. So Anka, do you want to go over that each for those?
Yeah, I think this is pretty much what I summarized before. The transfer piece is that's where you need a mandate. For people who are willing to or looking to use Hadoop in their enterprise, you have to have a system in place. So all the data can be just ingested from your discrete system, unstructured system, or whatever you're using at one place. So you can put it in Hadoop as your goal layer of storing all the data. Go ahead and transform and translate.
Yeah, okay, so a few words about the transfer. And the transfer basically is the pattern to sourcing data into Hadoop. And this is really, we need to make it a mandate, an enterprise-wide mandate, and to do that. And later in this presentation, and a few maybe slides later, we'll see what is different from this transfer in this 3T pattern compared to the traditional conventional ETL's extract. Okay, you can go.
Let's keep going. Yeah.
Go this. Did you go over the second
No, I think
one?
let's go to the next slide that explains more on the transfer side.
Okay.
Okay, so Data Hub is not a new concept, but I mean, how many of you actually use? How many of you are familiar with Data Hub concept? Most of you, I believe, right? At Sears, we use Hadoop as our data hub. So we ingest, as I said, all the data from different sources, right? We transform the data internally within the Hadoop, and then we file our vendor information, customer information, competitor information, whatever that's out there within Hadoop. And then on top of that Hadoop, we have systems like DataMeer and other applications that we use on our side to create reporting based off of, as I said, that one source of data. So that's really how we have used Hadoop. Now the interesting part of it is Hadoop, I mean, in the past, you could either archive data or use it, but Hadoop really provides you that strength, that unique ability where you can actually archive your data, but also use reporting in real time. And that's what we have done in the Sears holding with our concept of Data Hub.
Okay, as we said that 3T is enterprise big pattern based on Hadoop. But Hadoop is not just about infrastructure. We also need a data infrastructure. So this is what we call it enterprise data hub. Is Sears and Metascale's initiative to bring all the data into Hadoop. So that's the first T. Transfer is all about is this, that we want to build a repository, or you call it the reservoir, to gather all the enterprise data. We build a data infrastructure. So let's compare that Hadoop enterprise data hub with traditional or conventional data hubs. So on the left side of the column is the conventional data hub. So data hub, yeah, it's not a new concept, but conventional data hub is built using relational database or the conventional enterprise data warehouse. While Hadoop enterprise data hub, maybe data hub is not a good word, a most appropriate way to describe in what we want in our mind is that hub usually is some temporary place, and you have something from one or more sources, and you go through the hub and maybe stay there for a while, and then go to several or multiple destinations, like a transportation hub. Maybe Chicago is a transportation hub. But really what we want to do is not really a hub, but a permanent place for all the enterprise data. So maybe a reservoir or repository is a better word. So, so the difference is between relational or conventional data storage system versus Hadoop. So number two is that on the left side, that traditional data hub really doesn't have a consistent architectural style. You have many different major styles of data hub. For example, messaging and subscribe and what you call the publish and subscribe, and also operational data store, master data management hub, things like that. But in our pattern, we have a consistent architectural style. This style is three-phased and architecture that to cover the whole enterprise data lifecycle, from storage to integration and to analytics. And then another point is that the conventional data hub is heavily rely on the conventional ETL, and we are using 3Ts. So that's the big difference. And then the last is that I mentioned that the conventional data hub is intermediate and partial and siloed, but in our vision, Hadoop data hub or data repository should put all the data together and becomes the true center of your enterprise data. Okay, so let's talk about the first T. First T is transfer, sourcing data into Hadoop. So Anka, do you want to go over this?
No, I think let's go through it. I think in the remaining time.
Okay. So since we are talking about the pattern, so we use some headings from the Vienna book convention. So the first one is the intent. So intent is to capture continuously all enterprise data at the earliest touch points possible and deliver the data from all sources through all source data systems to Hadoop and store the data under HDFS. So here there's a few keywords there in verbs. So capture, deliver, and store. That's what we need to do. That's the activities that we need to do this phase. And also, and where and how and what is all the enterprise data. Not just partial data, not just the specific task data, but all enterprise data. And where and how is to go to the very source, and we said the earliest touch points possible. So maybe we can compare this to the ETL's extract to see, or maybe that's later. Okay, so this one we talk about why do we want to do this, and as we said, we really want to make Hadoop as a true destination or brand destination of all enterprise data. So we see some practice, and we even heard that in the past 2 days, we heard some practices that are using Hadoop, that are kind of like using Hadoop that when you are out of storage, for example, your data warehouse or relational database doesn't have enough space, so you use Hadoop as a rental space. We think that's really against the true purpose of using Hadoop. And we really want to use Hadoop, not just a temporary storage, or we call it a rental space, but permanent storage. You transfer data into Hadoop, and the data will stay there forever.
I think the key takeaway for people who are looking to do it in their enterprise is you need upper management buy-in into it. I mean, I'm sure you guys have similar silos where somebody's all about Teradata, somebody's all about SAS, somebody's all about IBM mainframe. So you do need that buy-in from a senior executive to really sponsor this project. So you have Hadoop as your core data source.
Next one. Okay, now we compare the first T, transfer, with ETL's extract. So the first item to compare is that conventional extract is bottom up, and Hadoop transfer is top down. What does that mean, top down? That when you do ETL, you always have a specific task. For example, you need a BI team has some data that or you want to summarize data, you want some weekly report, and then you go somewhere to extract that data. For Hadoop 3T pattern, data transfer really is not that you have something that a specific task that you want to do, is that you get data from everywhere. It really doesn't matter you have a specific task or not. We want all the data, into Hadoop. So that's the key difference. And also top-down is really not just a technical problem, it's actually you need enterprise management or upper management commitment and a vision and a strategy to do that. Otherwise, all different department, division will say, why should I give you the data, right? Has to make this a mandate, so to make it happen.
Yeah, so if you see the difference is bottom up versus top down, as I said before, it's a management governed initiatives. So top down always is, it should be driven by specific use case. So it's more of a strategic move, versus a technical way of doing it.
So when you do extract of ETL, you have a specific task or project. And when you do transfer in this 3T pattern, it really is proactive. You want to do it no matter what, and it doesn't matter whether you have a specific task or not. And then again, extract when you want the data actually is not available. That's why you want to go somewhere else to extract the data. And transfer, actually, when you keep doing this, actual transfer should not be a short-term task. Transfer should be a long-term task. Always keeping doing this because enterprise data generate new data and new types of data every day. So you keep doing this, and after a while, your data is already available when the data is needed for your analytics task, or at least partially available. So that's the difference. One is not available, and the other is at least some of the data is already available in Hadoop. So the last one is very important, that in ETL, when you extract data, you move data between your storage and your analytics tool or system. You move the data around between two or separate systems really without adding any value to the data. But when you do 3Ts in this circular flow, each time when you flow the data, when you complete one cycle, you actually add a value to your data, and so that's the key difference between these two approaches. The consequence. So what happens that if we keep doing this transfer in this 3T is that before the data is isolated, is disconnected in different heterogeneous enterprise data system, and even siloed data is siloed, isolated in different storage systems. But after that, you enterprise data is consolidated, is centralized in Hadoop. And before that, your data is segmented, but is segmented is not heterogeneous mixed, right? And you have POS data, you have inventory data, it's all isolated, segmented. But after that, your data is heterogeneous, is diverse, and it also is huge. So the last one says separated and partial. The other one is federated and consolidated. So the difference between the consequences are obvious. Okay, so implementation. This is really too easy to say and hard to do. Transfer is not an easy task. So always do a data gap analysis first. So when you keep doing this for a while, you already have some data in your Hadoop as your master data. So when you have a specific task, you want to do some analytics, you want to do some report, always do a gap analytics analysis to see what I can get directly from Hadoop as my reservoir, or what is still not there. I still need to either transfer or get from the very source. So always do that. Number two is forked ingestion in both batch and streaming if needed. So some of the task maybe is a high latency task. You don't very care about whether how late the data will come in. So you can afford to do the batch. But some of the tasks you really need the low latency, and you want to get the data very quick from the source. So you can consider using some approach that, for example, you can send a copy into Hadoop, but also in the meantime, you can use some mechanism to send the data to some non-batch mode storage, for example, NoSQL database like HBase or Cassandra, and through streaming. And then you do low latency analysis. And number three is I have a delivery plan. What's the delivery mechanism? It's all different. You can use existing mechanism, for example, messaging or web services, or even the secure data transfer, whatever that is available. Or you can use, if you have that option, you can use Scoop or Flume, that Hadoop related mechanism to do the delivery. And the last one is a very challenging one, to synchronize the source data into the data already in Hadoop. That's really very challenging, and there's no simple solution to, because each enterprise and each task is different. So that's really a lot of things, and then need to be working on that part.
Yeah, so the key takeaways you can take from transfer are as you say, ETL is short-term ways. When you need a project, you extract the data, transform it, and load it, and then transform it. As opposed to with the 3 Ts, it's for the long-term health of enterprise data. As I said, you keep it in Hadoop as a goal source, and then use it every time you need it. So the difference we have made from ETL, the closest comparison what we do is, instead of ETL, we do ELTTTT. Right? You extract one time, you load one time, and then transform as many times as you need it.
Okay, so let's go to the second T. Anka?
No, let's just keep going. I think we just defined the transform. So,
yeah, so can you go over the transfer, this one-liner transfer?
Yeah, the source data is now, when you transform the data within Hadoop, it's clean, it's standardized, and you're converting the data through dimensional modeling. So we will go through the same, what is the motivation, intent, the comparison with ETL in the upcoming slides.
Yeah, so basically here says that when source data is already in Hadoop, clean, standardized, and convert the data through dimensional modeling. Data transformation should be performed in place within Hadoop without moving the data out again for integration reasons. So there's a few keywords here that is important in this second T. So let's go to the second T is the, okay, so this one. Second T is about integrating data. So about the data integration within Hadoop. So the intent is keep the data flow beyond the ingest phase by transforming the data from dirty to clean, from raw to standardized, and from transactional to analytical, all within Hadoop. So we know that the ETL also has a T, transform. But this 3T's T is really different from ETL's T. The first difference, I think is a very important difference, is that we do that transformation all within Hadoop. We don't want to move the data out again to send it to your traditional data warehouse to do that. We want to do it in place within Hadoop. And why, we'll give you the reason why. And also, the transformation also, we highlighted a few tasks is to do the cleaning, to do the conditioning, and to do the standardization. So basically, the goal of the transformation is to convert the data from your operational and transactional data into analytical data that ready to do your really the last phase. Okay, motivation. Motivation is really about the low latency. We want to speed up the process, and we want to reduce the time to insight. Really, we want to shorten the cycle. So the latency and speed from raw data to this insight becomes the focal point, I think, in enterprise data analytics. I think all the effort now it seems that to try to work toward that direction, basically ultimately is real-time analytics. So if we do the transformation inside Hadoop and keep the data there, that will really help us to go toward that goal. Okay, do we have another one here? Oh, no. Okay. So implementation, how do we do that? So implementation is important that we partition the data into different partitions under Hadoop. So usually when you do the first T, when you do transfer, you put all your source data into one partition under Hadoop. For example, we do it, we say, under HDFS, we say incoming. All the data, raw data, you put it there. And then when you do the cleaning, when you do the conditioning, when you do the standardization, you move it to another layer under HDFS or another partition under HDFS. And we call it the gold layer data, that the data is really standardized and ready to use. And also in this standardized layer, data should be stored, we say, using the dimensional model. This is still, dimensional modeling is still a conventional data warehousing technology that you basically, you categorize your data and store data in the finest granular unit. So we call it, you can call it a tonic unit. So for example, you have location data. For example, our retail store has location data, and then your the most atomic unit of your location data will be store. Besides store number, you have address one, city, state, zip code, and maybe if you do online store locator, maybe you have altitude, latitude. Those information will be your dimensional data. Okay, number 2 is using dimensional modeling to transfer and standardize. Make dimensional data as the atomic. Okay, we'll cover that. identify all enterprise data entities and add finest grain attributes to each entity as dimension. We also mentioned that I gave you the location data as the example. So the last one is take a bottom-up approach, but also think about data usage across the enterprise, no specific task bound. So basically, dimensional modeling is a bottom-up approach. So different from the top-down one. This one, you need to do it from the bottom up. You go to the very lowest atomic level and do your transformation. But then, yeah, don't just think about I have a specific task and how do I transform my data. But think about that the data will be transferred once and it could be used by many, many teams, many, many specific tasks. So that's why we say that no specific task bound.
All right, we have 3 minutes and 6 slides to go. So I'll just run through it quickly.
Okay, so so transfer versus our second T versus ETL's transform. Same verb. What is different? Different one is inside Hadoop. We say Vitro. The other one is within Hadoop is Vivo, right? And using some approach, we really strongly oppose this approach that using Hadoop as a temporary rental space, kind of like your extension of your storage. We really strongly against that. And in our T, in our second pattern, is using Hadoop as integration pattern. And then the ETL's transform is a high latency one, and within Hadoop is a low latency one.
Yeah. The main point, sorry, the main point on that is on the latency side, as you know. Latency is from the moment when the data is created to when it is used, right? In the ETL world, there have been cases when you would not even get an answer, right? In how we use Hadoop in our world, we had 8 billion line of code that needed to process, and that was only on 10% of the data. Using traditional ETL systems, it took us over a week to run that. Now we run our jobs, that same 8 billion line of code job on 100% of the data, multiple times out of the day. So you see the latency is dramatically been different.
Okay, the third T is translate. Basically, it's really, this one is the last and the final stage that we making data products out of Hadoop. So the intent is 10 analytical data that are done in the second phase into the products that the management and end user can consume. And we say that we want to use tools to do that on top of Hadoop. So that's the key here is that any tools, it doesn't matter, is packaged, you buy it or you build it yourself, but it has to be integrated with Hadoop that we can run that. We can run that translation engine, we can do the presentation and using that tool that without also moving the data out of Hadoop and do that. So that's the key also. Okay, motivation is the low latency. Why do we want to use tool that is on top of Hadoop and integrate with Hadoop is also latency. And then the implementation and all the, you can go over that yourself, but the key here is that we want to use the tool that has a very good integration with Hadoop. It doesn't matter that you can buy it on the market, and we see a lot of new tools, exciting new tools here, or you build it yourself. That's about this T, and we really don't have much time to go over this T. Okay, so now we come back to this circular shape of a pattern. Again, this is a continual iteration of data flow. So go from one stage to the next stage, and then the data project out of the third and final stage will be used for the management and for the end user to generate more and new data, and then start another cycle of this enterprise data flow.
Yeah, so the takeaway is with this 3T flow, you can keep your enterprise data faster, easier, and clean, obviously. And then the more enterprise data that's generated, the more insight you can get from it. Again, you have one single source of truth. You can extract it every time you need a report, and you won't get two answers.
Okay, Q&A. Do you have any questions?
Yes. Can you take mic so others can hear it, please?
I think I heard
or
your
I can
question.
repeat the question.
What we are using the translation tools, we use the packaged one, the commercial one. We use data mirror, and we do also have other tools. I don't want to say their names. I don't want to say we give them. But yeah, we do use commercially packaged tools, but we also building our
in-house.
own.
Yeah. So we have analytics as a service internally. So we have some usage of data mirror that sits on top of Hadoop, and we've also in-house built tool that we use for our analysis.
If you have gone through those booths, you see some exciting in the translation engine and presentation tools. They're out there. I don't want to mention their names because we don't want to.
Free marketing, man. Let's do it.
Right.
Sorry, you had another question.
I have a question on the transformation. So are you using Java MapReduce to transform the data into dimensional model, or
are we using Java
MapReduce code, or what tool are you using to transform the data into a
We
dimensional
use
model?
all the tools, like existing traditional tools, and also Hadoop specific tools. And it really doesn't matter and how do you transfer, and really, so for example, specific Hadoop tools, we use Java MapReduce, we use Pig, we use Hive, we use all different things. And we also using some traditional approaches also.
Okay, and I saw the second question was, I saw that you store the transform data on HDFS, and so you don't use any data store like a NoSQL database to store the final data?
Oh, okay, that's a good question. So the transformation, the basic data unit should be stored first under HDFS. And then you can build whatever your data store on top of it. So using Hive, and you can use NoSQL database or columnar storage like HBase and Cassandra. And there's also some other new things that, for example, we saw this morning at the booth. Some of the things are very interesting. You can also do something like if you have a security requirement, you can do sales and you can do even increment. Those things you can build on top of it, or you can buy commercial packages.
Okay. One final question, how long did it take you to build this dimensional model on Hadoop?
Okay, dimensional model, it really takes time. That is not one day you can build alone, right? So keep doing this for a while, and then you will see the consequence, the positive result, it will come out. That it's not a one day thing.
You can hire Metascale to do it.
Sears and Metascale have been doing this for about more than 3 years. Okay. And we are still doing this every day. We still transfer data and do the transformation every day.
Okay,
a lot of time is spent on this one. And really the last phase is really, as long as you have the tool, it doesn't matter you buy it or build it, and you should run it. But a lot of time, I would say, at least over a third of the time is on the first two phases.
Thank you.
Thank you.
Okay. Any other questions?
Okay, well, thank you so much for your time.
Thank you.